Okay, January 2010, we'll solve questions related to topic momentum only. Question 3, what could be the answer for question 3? A radium nucleus decay by emitting an alpha particle. The speed of recoil nucleus is small as compared to that of alpha particle. This is because, what is the reason why the recoil nucleus is having a smaller speed compared to alpha particle? What could be the answer? A, B, C, or D?
Assalamu alaikum.
Walaikum assalam, Hamza. We are discussing the past paper question, Hamza. This is January 2010. Question 3. What could be the right answer? What do you think should be the right answer? A, B, C, or D?
Should I say it?
You can just mention, or you can say, or you can use a chat to mention the answer.
D.
Yeah, D is the correct answer, because what happened when it emit out, if example, if this was the original nuclear, when it emit out alpha particles, so if alpha particle, which is 2 proton and 2 neutrons, are coming out, so mass of the alpha particle is less or small. So if mass is small, its velocity will be much higher. But the recoil nucleus, as alpha particle is released, the recoil nucleus will move in opposite direction, but it will have the same momentum. But why it is recoiled with a smaller speed? Because it will have greater mass compared to alpha particle, so it will have a smaller speed. That's why D is the correct answer. Question 1. What could be the answer? The area under a force time graph represent what? Acceleration, change in momentum, displacement, or kinetic energy?
Sir, do I type in the chat or say it?
Type in the chat.
Okay.
Yes, correct, Hamza. What about Taha? What could be the answer? B is the right answer, because when you have force in time graph, force is on y-axis and time is on x-axis. The area under the graph for force in time, it's if a variable and force is there at a constant change in this area, because area of any graph is the quantity on x-axis multiplied by quantity on y-axis, or quantity on y-axis divided by quantity on x-axis. The area is a product of the two quantities, whereas slope is the ratio of the two quantities. So area of force multiplied by time, as we know, it's impulse. Impulse is a change in momentum. So B is the right answer. Question 18. A student is using a Newton's cradle. This consists of set of identical solid metal balls hanging by thread from a frame so that they are in contact with each other. You can see these are in contact. She initially pulls one ball to the side. She pulls one ball to the side and she releases the ball. So when she releases the ball, this ball will collide. Then what will happen? It collide with the nearest stationary ball and stop. So the ball, when it collide, it will stop, and the ball which is furthest to the right will immediately move out. The middle three balls remain stationary or will not move. Means if she release one ball from here, it will collide and one ball will move to other side. So the question is, explain what measurement the student would take and describe how she would use them to investigate whether the momentum has been conserved in this event. So how a momentum is conserved in this event, or what measurement should be taken to show that the momentum is conserved in this? How we can show that the momentum is conserved? So measurement of the time. Okay, one thing. What else? Because we want to show
calculate the ball's
mass of
as
the
well
ball. Okay.
for velocity.
So velocity cannot be. You have to calculate. You cannot measure the velocity. Velocity can be calculated by using a formula. So what you should know to show that its momentum is conserved. So you should know the distance, first distance release, and how much time it will take. So distance divided by time, what you will get velocity. And because this consists of set of identical solids. So if it consists of set of identical solids, so we don't have to bother about the mass. If the velocities are conserved, it means momentum will also be conserved. So because the momentum is a product of mass and velocity, if we don't know the mass, that's okay, because I can find the velocity of the object 1, the ball velocity of this ball 1. An example, if this is ball 1, 2, 3, 4, 5, then I should measure the distance moved by ball 5 and distance divided by time. What I will get the velocity of the last ball. If their velocities are same, because their mass, they already mentioned their identical masses. So if their velocities are same, then the mass will also be conserved.
Okay.
Is it clear?
Yeah.
So we can measure either a distance, height, or time. Then we can calculate the speed on impact, and we can compare the speed after the impact. And if two speeds are same, it shows that the momentum is conserved. Is it clear? This is a 4 marks. So 1 mark is for mentioning measure distance, time. Second mark is for mentioning calculate the speed. Third mark, measure the speed before the impact. Then fourth mark, measure the speed after the impact. If speeds are same, then it shows that the momentum is conserved. Mass, why the mass is not important? Because the particles or the balls are identical. So if I don't know the mass, like the momentum before is m1 v1 and momentum after is m2 v2, but because these masses are same or identical, so if there is a change in velocity, that I can identify there is a change in momentum as well. If there is no change in velocity, there is no change in momentum. The second part of the same question, the student makes the following observations. The ball on the right returns and collide with a similar result that repeat itself number of times. After a while, the middle ball are also moving, and shortly after, the balls all come to rest. Discuss the observations in terms of energy. So what they mean here, like when you release this first ball, it will collide and the last ball will move. Then this last ball will return and collide. The first ball will also again move. And this will continue, but so the balls on the right return and collide with a similar result. This repeats itself number of times. Then after a while, the middle ball also are moving, and shortly after, all the balls are at rest. How you explain in terms of energy this observation? So first thing, you should identify whether a collisions are elastic or inelastic. What do you think? Collisions are elastic or inelastic?
At first, inelastic.
Inelastic. Why? Because the thing is, as the system is returning back to its, like, you initially there was a kinetic energy, but what happened at the last, there will be only internal energy. So all of the energy or energy changes to other form. So the collision likely to be inelastic. So you'll mention the collisions are inelastic. Why the middle ball is moving? Because some of the energy is transferred to the middle ball. And eventually, why all the stop? Because all of the energy is transferred. There is no kinetic energy. Is it clear? So the distribution of the marks or mark distribution, that collisions are inelastic or kinetic energy is transferred during a collision, or kinetic energy is not conserved. The kinetic energy transferred into heat energy, which is transferred to, or internal energy, which causes the movement of the metal ball, and eventually all the balls stop because all the energy is being transferred. Is it clear?
Sir, they stop because the energy is transferred to the surrounding?
The energy is transferred to all the balls as internal energy, and some of the energy transferred to the surrounding in the form of sound or heat energy.
Okay.
What could be the answer? The momentum of the particle is P. The kinetic energy of the particle is double. The momentum is now question number 1. What could be the answer?
Sir, A?
A is the right answer. Because how you relate the momentum and kinetic, as we know, momentum is a product of mass and velocity, and kinetic energy is half mv square. So as the kinetic energy is half mv square, there is a formula which relate, if I multiply and divide this by mass, so it will be half m square v square divided by m. M square v square is basically momentum square. So I can say kinetic energy is 1 by 2m into p square. Or we can say p is equals to square root of 2m into k. That's a formula which relate momentum with kinetic energy. So momentum is equals to under root of 2 into mass into kinetic energy. They mentioned the kinetic energy is double, so this become 2 ke. So when this become 2ke, I can write like this. This will be 2m into 2ke and in a square. When we solve, like 2m and ke is equals to p. This is a new momentum when the kinetic energy is double. So this will be 2mke, the kinetic energy in a square root, and multiplied by under root 2. It's the same thing. I just separate. Why separate? Because under root 2 mke is equals to momentum. So new momentum is equals to under root 2 of the original momentum. Is it clear? A is the right answer for this. Any doubt in this? Question 2. What could be the answer for question 2? A, B, C, or D? The diagram represents the collision between the two subatomic particles, such P and Q, moving with momenta 1 and 2. After the collision, they have momenta 3 and 4. Which vector diagram best describes the relation between moment? Because the momentum before collision should be equal to momentum after collision. So what is the answer for this? A, B, C, or D? You have to apply a vector addition rule before momentum, the momentum before collision. So before, this is 1 and then 2. And momentum, so what is the resultant momentum? This will be the resultant momentum. And what is momentum after collision? Because if I say momentum before and momentum after are same, it means the resultant momentum before is equals to resultant momentum after. And then momentum after collision is 3 and 4. So first I will draw 3 and then I will draw 4. So my starting and ending point will be same because we have the same resultant. So which one it matches with, A, B, C, or D?
C.
So it matches with C, so C is the right answer. Is it clear? Because resultant of 1 and 2 is same as resultant of 3 and 4, and that is the conservation of the momentum. Okay, discussion. The mass of the neutron is Nu, where N is the relative mass of a neutron and its initial velocity is x. The nitrogen atom has a mass of 14U. It is initially stationary and then it knocked out of knocked out of the target with a velocity y by collision with neutron. Show that the velocity z of a neutron after collision can be written as this. So how you can write this? So momentum before collision, if the momentum is conserved, the momentum before collision will be equal to momentum after collision. So we have the formula m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2. So initially the mass of the neutron, what is the mass of the neutron? Mass of the neutron is given Nu. And velocity at which it is moving, that is equals to x. U is like a unit, atomic mass unit, plus mass of the nitrogen is what? It's 14U. But initially in the question they mention it is stationary. So if it is stationary, so its initial velocity is 0. Then mass of a neutron, show that z velocity, show that the velocity z of a neutron after collision can be written. So neutron velocity after the collision is what? The mass of a neutron is n and velocity is given z after collision. Plus mass of the nitrogen atom is 14 and velocity at which it moved when neutron hit its y. So that's equal to y. So we will solve this. This is nx. 14 multiplied by 0 is 0. This one is nz plus 14y. 14y will move other side. So we can say nz nx minus 14y is equals to nz. And then we need z, so n is multiplied, z will be divided. So we can say nx minus 14y divided by z, divided by n is equals to z. Is it clear? We use
Yes, sir, clear.
a principle of conservation of momentum and just a variable because we don't need a exact value here. We just have to show an equation that it's giving according to the question.
Sir, in the first step,
Yes.
when you wrote mass for M1,
Yeah.
you only wrote N and not NU. Why?
Yes. Why I did not use the full one? Because what is the mass of the neutron? N is the relative mass of the neutron. What is U? U is actually a unit. Like example, if I say in numbers, if I say the mass of the neutron was 1.6 into 10 to the power minus 27 kilogram. Okay. So if I substitute the value here, I just substitute the magnitude. I don't substitute the unit. I don't write like 1.6 exponent minus 27 kg. So what is U here? U is the atomic mass unit, because neutron is mass is 1.67 exponent minus or 1.6 exponent minus 27 kilogram, or you can also say 1 atomic mass unit. So U is the atomic mass unit or unit of the mass, and N is the relative mass.
Okay.
So I did not substitute the unit. That's why you can see here for nitrogen also I wrote 14. I did not write 14U. Why I did not write 14U? Because U is a unit for the mass. Like kilogram is their unit, gram is their unit. U is also a unit of the mass, which is called atomic mass unit. So I simply substitute the magnitude, not the unit. 13. Question 2. What could be the answer? Question 2. A body initially at rest explodes into two masses. These masses move apart with a speed v1 and v2. The ratio of v1 over v2 is equal to. You can use the principle of conservation of momentum. Yeah, B is the right answer. Look how you will use conservation of momentum. It's m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2. If something initially at rest, so initial momentum is 0, means this whole part is 0. Okay. And if it explodes into two masses, so to conserve the momentum, if I say this was an object and this object explode into two masses, so if one mass is or one part is moving towards right, the other part should move towards left to conserve the momentum. So if mass 1 is moving with velocity v1, then mass 2 should move with velocity minus v2. Why? Because the original momentum is conserved, the final momentum should also be conserved. So mass is m1, velocity is v1 minus m2 v2. Why I am writing minus? Because they should move in opposite direction. Momentum should be conserved. So if first one is having a momentum positive, the other one should have a negative momentum. Now if you solve, if I move this to other, we need a ratio of v1 over v2. So if I move to other side, it will be m2 v2 is equals to m1 v1. And when I take the ratio, so m2 divided by m1 is equals to v1 divided by v2. So that's why B is the correct answer. Is it clear?
Yes.
Question 6. What could be the answer? Two identical.
B, sir.
Yeah, that's correct. B is the right answer because they're two identical spheres. So momentum will be mv, and here momentum will be mv, but one I take positive, the other one negative. So if initial momentum is 0, the final momentum should also be 0. So B is the correct answer. Question 7. A cyclist travel along a straight horizontal road at a constant or a steady speed. The net force is 20 Newton, is applied for 6 seconds. The change in momentum is what could be the change in the momentum? Impulse.
C, sir.
Yes, impulse is a product of force into time. That C is the correct answer. So just force multiplied by time. Force is 20 and the time interval was 6. That's why C is the correct answer. So this one is January 2014. Question 3. The graph shows how the force on a stone being fired from a catapult varies with the time. Which quantity represents the shaded area? Area under the graph for force in time.
D.
C is the right answer. The change in the momentum or impulse. A railway truck of mass 20,000 kg is moving at a speed of 4.5 meter per second. It catch up and collide with a loaded truck of total mass of 60,000 kg, which is moving in the same direction at 1.5 meter per second. The graph shows the speed of heavier truck before and during and after collision. By mean of calculation, show that the speed of the lighter truck after collision will be 0. So you have to show that the speed of the lighter truck, means the 20,000 kilogram truck, after the collision will be 0. So how you can show this? So for this, you have to use a conservation of the momentum again. That the momentum before collision should be equal to momentum after collision. So we'll take the formula m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2. M is the first mass, which will be, just I will mention how to substitute the values. 20,000 multiplied by initial velocity was 4.5. The second mass was 60,000 and initial velocity is 1.5. But after collision, you can see the velocity of the truck, because the heavier truck, the after it's 3. So M1 is 20,000 multiplied by its velocity v1 plus m2 60,000 and multiplied by velocity is 3. So you will solve this, the final answer, because when you subtract, you will get 0. Is it clear? This part, like 20,000 multiplied by 4.5.
Clear, sir.
Just you have to use the values and show that the final answer will be 0. Add a second line to the graph to show the speed of a lighter truck before, during, and after collision. So before the collision, it is 4.5. So you will continue till 4.5. It will be straight line. And then it becomes 0. So during a collision, it is decreasing. And then it changes to So this is 4.5, and then it decreases